In number one, we want to find the vertex focus, and directrix of this parabola. So this is a parabola that faces up. All right, we know that because the x term is squared and the coefficient of x squared is positive. All right, and y is not squared. Y is a linear term. So its face is either up or down, and because of this coefficient being positive, we know it faces up. So here's the information that we need to know about a parabola facing up. This is the standard form of the equation. And here's a picture where HK is the vertex, and then here's the focus. It's p units above, and those are the coordinates of the focus. And this straight line is the horizontal line, is the directrix, and it's p units below the vertex, so that would be y equal k, the y coordinate, minus p. And just to remind you what the directrix and the focus are, well, the definition of a parabola would be the set of points that are equidistant from a focus and from a line. So the way I drew it, this parabola is supposed to be the set of points equidistant from, let's say, this point and this line. So if this were drawn correctly, this distance would be equal to this distance for every point on the parabola. So we want to put this in this standard form, so what we're going to be doing is completing the square. First step will be factor out the coefficient of x squared. So we're going to factor out 1/2. So let's write y is equal to 1/2 x squared plus, if we factor out 1/2, we're going to have to multiply by 2x plus 9. All right, make sure that's correct. Just multiply back, and we have 1/2 x squared plus x, which we have here, plus 9 over 2. All right, ready to start completing the square. So we're going to use these two terms to do that. So that would be x squared plus 2x. Half of 2 is 1, squared is 1. So half the middle term squared is 1, so we're going to add 1, subtract 1. All right, now this is our perfect square. So let's factor that as a perfect square. So that's x plus 1 squared. And here we have plus 8. All right, we're getting closer to this form. Let's now multiply through by 1/2. Eight times 1/2 is 4. Subtract 4 from both sides. And finally multiply both sides by 2, and we'll be there. So in this form, we can read off the vertex. So we have a vertex of -1 because of that x plus 1, and positive 4 because of that negative 4 there. So that's the vertex. We can also read off the value of 4p. That's 4p equal 2. So p is equal to 2 over 4, or 1/2. So once we know that, you see we can get the focus. So the focus is -1, and then the y coordinate plus p. So that would be 4 plus 1/2. And we can get the directrix. We just take the y coordinate and subtract p, the y coordinate of the vertex. And we have for the directrix the line y is equal to 4 minus p, 4 minus 1/2. In number 2, we have a horizontal parabola facing either right or left. We know that because we have a y squared term, and x is not squared. Since the coefficient of y squared is positive, then it opens to the right. So this is the picture. And here's the information that we have to know about a parabola that opens right-left. Here we have the vertex, HK, and the focus is going to be P units to the right, so that would be H plus P comma K, and the directrix is a vertical line, P units to the left, so that would be H minus P, x equal H minus P. Now, if this parabola opens left, then P is negative, but everything else, everything holds. We still have H plus P and H minus P, everything holds, just P will be negative. All right, and this is the standard form for the equation of a right-left parabola. All right, so in order to find vertex focus directrix, we're going to complete the square. So let's do that. So here we have x equal, let's factor out 1/8, the coefficient of y squared. So here we have y squared minus, okay, when we factor out 1/8, then inside we're multiplying by 8. So multiplication by 8 would yield 24 divided by 4, that's 6y, minus 23. Okay, just check that by multiplying back, and you see we have 1/8 y squared. Here we have 6 over 8, which is the same as 3 over 4, and here we have 23 over 8. All right, we're ready to start completing the square using those two terms. So let's do that. And we have y squared minus 6y plus 9 minus 9 minus 23. And let's factor as a perfect square, so that would be y minus 3 squared and minus 9 minus 23, we have negative 32. All right, let's multiply through. And 32 divided by 8 is 4. Let's add the 4. And we have x plus 4 is equal to 1/8 y minus 3 squared. Okay, we're almost there. Just multiply both sides by 8, and we have 8x plus 4 is equal to y minus 3 squared. All right, that's of this form, so 8 is 4p. 4p is equal to 8, so p is equal to 2. All right, and then here we have the vertex. The x-coordinate is minus 4, and the y-coordinate is 3. All right, now let's find the focus. So we add p to the x-coordinate. The focus is minus 4 plus 2. And then for the directrix, we have x is equal to the x-coordinate minus p. X-coordinate of the vertex minus 4. And now we're going to subtract p minus 2. Okay, so x equal minus 6. That's the directrix. In number 3, we want the equation of the parabola of this form that goes through these points. So we're just going to substitute in. All right, so here we have y equals ax squared plus bx plus c. And we're going to put 0 for x and 3 for y. So when we do that, we get 3 is equal to c. All right, let's go on and substitute in the point 1, 4. So now we have y is equal to ax squared plus bx plus 3. We just found that c is equal to 3. All right, we're substituting in 1 for x, so we're going to put a 1 here and a 1 here, and 4 for y. So we have 4 is equal to a plus b plus 3, or 1 is equal to a plus b. All right, and now let's see what we get when we substitute in minus 1, 6. So let me rewrite this. Let's see, we have y is equal to ax squared plus bx plus 3 again, and now we're putting a minus 1 here for x, and we're putting 6 for y. So we get 6 is equal to a times minus 1 squared, so that's just a, minus 1 times x, that's minus b, plus 3. Okay, so we have 3 is equal to a minus b. Let's add these two equations together. 1 equal a plus b, and 3 is equal to a minus b. And we get that 4 is equal to 2a, or a is equal to 2. All right, in this equation, if we just put the 2 right here, and then subtract 2 from both sides, we get that b is equal to minus 1. So we have a, b, and c, and we can just write down our equation now. Let me write it up here. So we have y is equal to a is 2, 2x squared, b is minus 1, minus x, and c is 3. In number 4, we have the equation of an ellipse, and we want to find the major axis, the minor axis, and the foci. So here's a picture of an ellipse, and this is the center. These are the foci, and I'll just remind you that the way we define an ellipse is as follows. If we have two foci and we have, let's say, a piece of string attached to both, the one end here, one end there, then we can trace out an ellipse by pulling the string as far as possible and just going around. So basically the distance from any point on the ellipse, the sum of the distances from any point on the ellipse to both foci is going to be constant. All right, so here, this is an ellipse that we call horizontal. That is, the major axis is horizontal. All right, and if the major axis is horizontal, then the larger number is going to be underneath x minus h squared. So we're always assuming that a is bigger than b. All right, so since a squared is underneath x minus h squared, I'm assuming that that this number is larger than this number, and as a result we have a horizontal ellipse. So here, this ellipse is in standard form, and we want to get this information. We also have this relationship between c, which determine the foci. The foci are c away along the major axis, c away from the middle, from HK. So this one is c to the right, and this one is c to the left. And we have this relationship between c, a, and b. Now a is the distance, is half the distance of the major axis. It's from here to what we call a vertex of the ellipse, from the center to this rightmost point. And b is for a horizontal ellipse, b is the distance from the center to the top. And we have this relationship here. All right, so what we want to find is this information. Okay, so in this ellipse, 16 is equal to a squared, and 4 is equal to b squared. So we have a is 4, and b is 2. We also can read off the center. So we have the center is x-coordinate minus 5 and y-coordinate 3. And since the larger number is under is under x, 16 is under x, then we know that this is horizontal, and the major axis is horizontal, and it goes through the center. This is the center. So the major axis is y equals 3. That's a horizontal line. Starts with y equal. Horizontal line is the form y equal a number. So just pick off the y coordinate of the center, and y equals 3, that's the major axis. Then the minor axis will be vertical. All right, so the minor axis is vertical. So that's of the form x equal, and just pick off the x coordinate, x equal minus 5. And now we want to find the foci, so we have A and B. So we'll use this little equation to find C, and from C we'll get the foci. So let's do that. So we have C squared is equal to A squared minus B squared. So C squared is equal to A squared is 16. So let me just write 4 squared, and B is 2, so 2 squared. So that would be 16 minus 4, or 12. C is equal to 12. Sorry, C squared is equal to 12. So C is the square root of 12. And now we can get the foci. Since this is horizontal, then the foci are along the major axis. So they're going to be positioned C to the right and C to the left of the center. So the foci are, here's the center, so that would be minus 5 plus the square root of 12. That's to the right of the center, and minus 5 minus the square root of 12. So that's to the left of the center. Okay, so there we have all the information. All the information that we were asked. In number 5, we want to find an equation of an ellipse. And we're given the center, and we're given information about the major axis and the minor axis. All right, so let's start by just drawing a little picture. The center is 1, 2, so this will be the point 1, 2. And one of these will be the major axis, and one will be the minor axis. We'll see which one in a minute. Now it says that the major axis has endpoint 1, 6. So it's going to be above 1, 2. Okay, so it's actually 4 above. So there's 1, 6, right? 1, 6 is 4 units above 1, 2. All right, so that means that the bottom of the ellipse will be 6 below. Sorry, 4 below. This one's 4 above, 4 below. 1, 2, 3, 4. So it'll be right here. So just subtract 4. 2 minus 4, that's minus 2. Okay, so now we see that if it says that the major axis has this endpoint. So we see that we have a vertical ellipse. Major axis is vertical, and it's given by x equal to the x coordinate 1. All right, so that means the minor axis is horizontal, and that will be given by y equal the y coordinate of the center, y equal 2. Okay, and let's see. It says the minor axis has endpoint 4, 2. All right, so here's 1, 2. So it's going to be along this same line, y equal 2, and it's just going to be 3 units to the right. 1, that's 2, 3, and that's 4, 2. All right, so we can go 3 units to the left and draw the ellipse. All right, so it looks like a football standing on on its point. Okay, we want the equation of the ellipse. Well, we were given the vertex. Okay, this says find the vertices of the foci. That's not what I meant there. Just find the coordinates of the foci. Just find the foci. That's what that should read. Find the foci. All right, let's write down our little equation. A vertical ellipse is of this form. We put B underneath the x. And we still have c squared equal to a squared minus b squared. We're assuming that a is greater than b, both for a vertical and horizontal. So since we put a underneath y, that means vertical. All right, let's write down our equation. Let's start filling in. So we have x minus 1 squared. And here we have y minus k, y minus 2 squared. Now, we drew this picture, so we see what a and b are. So a is, since we had this 0.16, we see that a is 4 units, 1, 2, 3, 4 units above. And that's going to be, 1/6 is 4 units above. So that's going to be our value for a. So a is 4. All right. Remember, a is half the length of the major, and b is half the length of the minor. So b goes from here to here. B is 3. All right, we're putting b underneath x. So this would be 3 squared. And we're putting a underneath y. So this is 4 squared. All right, that's our equation of ellipse. Now we just have to find the foci. So let's do that. Using this equation, c squared equal a squared minus b squared. So we have c squared is equal to 4 squared, the larger one, minus 3 squared, 16 minus 9. Okay, so we have c squared is equal to 7, so c is equal to square root 7. And now the foci, since this is the major, the foci are going to be along the major axis. So it'll be square root 7 above the center and square root 7 below. So we're just going to add and subtract this time from the y. So the foci are 1, 2 plus square root 7 for the one above, and 1, 2 minus square root 7 for the one below. All right, so there we have our equation. And there we have our foci. In number 6, we want to find the center, major axis, minor axis, and foci. So we want to put this in standard form. So we're going to complete the square in both x and y. So first, let's put the x's together. 9x squared plus 36x. And let's put the y's together. 4y squared minus 24y. And maybe we'll subtract 36 from both sides. All right, let's factor out the 9. So we have x squared plus 4, and I'll leave some room here. And factor out the 4, so we have y squared minus 6, and I'm going to leave some room here. All right, sorry, I have an x here and I have a y here. Okay, x squared plus 4x. All right, now complete the square. Half of 4 is 2, squared is 4, so I'm going to add 4 and subtract 4. Because of this 9 out here, out of parentheses, I'd rather do everything inside the parentheses. Add 4 and subtract 4 right inside the parentheses. And here, half of 6 is 3, squared is 9, so I'm going to add 9, subtract 9 right inside the parentheses, and complete this write as a perfect square and write as a perfect square. So let's do that. So here we have x plus 2 squared minus 4. And here we have y minus 3 squared minus 9. All right, we're getting there. Let's open up these parentheses. 9 x plus 2 squared minus 36 plus 4 y minus 3 squared minus 36 is equal to minus 36. All right, let's just cancel that. We have a 0 on the right-hand side. Add 36 to both sides, and we get 9x plus 2 squared plus 4y minus 3 squared is equal to 36. Now, standard form has a 1 on the right-hand side, so let's divide everything by 36. And this example was formulated so all the numbers work out nicely. Here, just reduce, and we're going to get x plus 2 squared over 4. And reduce this way, and we're going to get y minus 3 squared over 9 is equal to 1. So here we have the ellipse in standard form, and we can start answering the questions like center. Okay. So we have the center minus 2, 3. Major axis, well, we have the larger number under y, so it's going to be vertical. So this is a squared, and this one's b squared. A squared is always the bigger one. All right, so it's going to be major axis. It's vertical, so that means x equal the x coordinate of the center. Minor, well, the minor is horizontal, so that's going to be y equal the y coordinate of the center, y equal 3. And now foci, well, for the foci we're going to use this little equation. C squared is equal to a squared minus b squared. So we have c squared is equal to 9 for a squared minus 4 for b squared. C squared is equal to 5, and c is the square root of 5. Okay, all right, so now since the major axis is vertical, remember that's because the larger number's under y, then the foci are above and below rather than right and left, above and below the center. Root 5 above and root 5 below. So the foci are minus 2, 3 plus square root 5, and minus 2, 3 minus square root 5. And that's all the information that we were asked to give.